another minute or so before we get started. We're so happy to see all of our science friends from across the state. It's been a few weeks since we held our last virtual meeting. For those of you that were joining us for those weekly and then bi-monthly virtual meetings, we're glad to see you back. And if you're new to this group and this opportunity, welcome. We'll become fast friends, and hopefully you'll stick around with us for the summer for some additional opportunities to come together and learn together. So just so you know, today's webinar is going to be recorded. So Susan is going to help us out and start the video recording so that we can get started. And Susan, if you'll give me a thumbs up when
it's going.
We're ready. All right. So welcome this afternoon to the Oklahoma State Department of Education's virtual webinar on supporting the new science standards implementation. My name is Tiffany Neal, and I'm the Executive Director of Curriculum and Instruction here at the State Department of Education. And before we introduce everyone else and we get started with our slide deck, I just want to let you know that you have the chat feature available to you over in the chat box. So if you have any questions, feel free to message one of us privately or to just send that question in the chat box itself. So I'm going to share my screen so that we can all see the presentation for today. And our colleagues on the call today are going to share a link to that presentation in the chat box so you have that available to you as well. As I mentioned, I'm Tiffany Neal, but I'm very excited to present today, or to announce today and share with you that we have a new Director of Science and Engineering Education, Heather Johnston, who is joining us. And
Hello.
She'll be, yeah, hi, Heather. She'll be sharing a little bit of information with us later this afternoon. Susan Ray is our Science Instructional Specialist, and many of you may know her from the Oklahoma Excel program. She also supported our state in the development and revision of the science standards process, as well as Donna Schweitzer, who is a Science Instructional Specialist with us as well, who supported us with science standards revision, and will be supporting us this year with updates to the Oklahoma curriculum frameworks for science. And I apologize, everyone. All of a sudden, the stop sharing just kicked me out, so we're gonna try this again. All right, just as technology often does, we've run into a few complications here. Susan, would you mind trying to share your screen and seeing if the presentation will come up for you? All right, if you'll scroll all the way up, Susan.
Yep, I'll do it.
Great, thank you so much. All right, so Susan, if you'll scroll forward for us. Great. And I believe Heather is going to share with us a little bit of how we can get started and get to know each other a little bit through the chat area, as well as a naming structure we'll use to support our work today together.
Yes, all right. So later on, we are going to break up into some breakout rooms based on grade bands. And so to kind of help us put you in the right spot, we're going to ask you to rename yourselves in Zoom. So what you're going to want to do is find the 3 dots. You can either hover over your picture or down at the bottom of your screen where the little more is. If you click on that, you should be able to rename yourself. And then we're going to put a number in front of your name associated with your particular grade band. So you can see that on the screen. So like if I'm going to be participating in the 3rd through 5th grade band. So if you see my name, there's a 2 in front. we just ask that if you're pre-K through second, place a 1, middle school is a 3, and then you can see how the high school sciences are broken up as well. If you have questions. Yes.
I do have a question. I am no longer a classroom teacher. I offer materials for renewable energy. I teach Oklahoma Renewable Energy Education Program to teachers.
Mm-hmm.
But we are...
Jan, if you don't mind, we'll just kind of make a blanket statement here. If you would just select a grade that you would be interested in being a part of, and that will allow you to break out into a session. And also, just for time's sake today, if you do have a question, if you would put it in the chat box, and then we'll be monitoring that throughout the session and have some times where we'll respond to those. So thank you so much for that. And it appears that we have the slide deck working, and we have the link to the slide deck in the chat box, so you can check that out as well and follow along with us.
Is that the telephone? Is that the chat box?
Yes, ma'am.
Okay.
Yes,
Okay, so for today, we do have 3 goals that we hope that we are addressing through our conversations and collaborations today. We are going to take a look at the different attributes of quality science standards and how the revision teams were addressing those and the different shifts that we will investigate today as we move through and work through the different documents. We are also going to talk a little bit about some timelines and resources to help with the shifts within our standards. And if you would like a link to the agenda, we did put it there at the bottom so you can kind of follow along. And with that, I'm going to pass it back to Tiffany.
Thanks so much, Heather. So again, follow along with the presentation, and you can access all of the links in today's presentation. And I see a few chat questions already about how do I rename myself so I can be a part of the breakout sessions. And we have some wonderful science teachers on the line today who are sharing how to do that. We'll also have a little bit of time before we go to our breakout spaces where we'll go over those directions again and support everyone to ensure they make it into a breakout group. So just quickly, we know several of you have been a part of following along in the standards review or revision process over the last year or so, but we wanted to highlight for those that were new, just a few aspects about the standards revision process and some of the high-level shifts that you may notice in the new Oklahoma Academic Standards for Science. Next. As many of you know, we review or revise standards every 6 years in accordance with the state textbook adoption process. And so science was up for review or revision this last year, and we began that process a little over a year ago, with the standards being approved the end of this legislative session. Next. Also, one thing to share with you is that in our review or revision process, we had several committees of education stakeholders and educators, science educators, who helped us develop a process whereby we reviewed the standards to determine what modifications, if any, should be made. And the way in which they went about that review process is that they identified what they considered attributes of quality science standards. And these became the criteria for which they would analyze every standard from the 2014 science standards to determine if any adjustments should be made. Those attributes included an emphasis on ensuring that standards represented a rigorous learning goal to support college and career readiness, that the standards were scientifically accurate, and that they represented a clear component of progression of learning across grade bands. Additionally, on the next slide, the committees wanted to ensure that the standards were clear, concise, and comprehensible to science educators, that they led to instruction that is interesting and relevant to all students in diverse student populations, and that they included an emphasis on the integration of the 3 dimensions of science. If that's new to you, that term or phrase, the 3 dimensions of science, we want to share with you just quickly where that research base comes from. On the next slide, you'll notice a document titled The Framework for K-12 Science Education. This document was produced by the National Academies of Science in 2010 and became the document that informed both our 2014 standards review as well as our 2020 standards review. This document also informed the development of the next generation science standards, which we utilized as an informational document in our review process as well. Next. The 3 dimensions of science that you'll find outlined in the framework for K-12 science education are science and engineering practices. So these are the 8 science and engineering practices that are embedded in our Oklahoma academic standards for science, and they represent what students should be able to do in the way of science and engineering practices throughout their K-12 science experience. So this is where students would engage in investigations. They might construct explanations for events in the natural world or phenomenon, or engage in scientific argument from evidence. This is one dimension in the 3 dimensions of science that we'll see in our standards in just a moment. Next. The second dimension, known as cross-cutting concepts, are still a bit new to some folks. There are 7 cross-cutting concepts that you'll see throughout or embedded in our standards, and these cross-cutting concepts really represent those ways in which scientists and engineers think about the world as they encounter them, or as they're designing solutions for the world, solutions to problems. So this would be where a scientist or engineer might look at a situation in the real world, and they might notice that there are a set of patterns that appear as they're analyzing an ecosystem, and they might wonder why those patterns exist, what's causing those patterns to exist. So these are the constructs with which we hope students will really learn how to think like scientists and engineers. And again, those play out in our standards throughout that K-12 experience. Next. And the third dimension, known as the disciplinary core ideas, are really those sets of science concepts that appear in the domains of physical science, life science, earth and space science, and engineering, technology, and applications of science. So these might be more familiar to most folks, those science concepts that you are really familiar with teaching about and engaging students in learning about. Those 3 dimensions of science and engineering practices, cross-cutting concepts, and disciplinary core ideas. Next. Show up in our standards documents in these ways. So here's an example of a standard as it's laid out in our standards document. This happens to be a 3rd grade standard, and we can see that from the very first row on the screen where it says 3rd grade. Under that 3rd grade title, you'll see motion, stability, forces, and interactions. This is a disciplinary core idea category. So this particular category comes from the domain of physical science. And we see there on that 2nd row, PS2, PS standing for physical science, lets us know that this particular standard is going to be under that domain of physical science. The actual standard is in that 3rd row there, where it says 3 PS21, plan and conduct investigations on the effects of balanced and unbalanced forces on the motion of an object. That is also known as the performance expectation. This is the learning objective, the skills that we want students to have by the end of instruction that you may be providing in school. So we want students to be able to do that by the end of their school year. The standard or performance expectation name is 3 PS21, 3 indicating 3rd grade, PS indicating that it comes from the domain of physical science, and 2.1 really gives it that unique standard naming system for this particular standard. You'll also see in the standards documents for every standard or performance expectation, you'll get information, further clarification about what the intent of the standard is and how far you want to go when you think about assessing students on that standard or performance expectation. That information comes through the clarification statement and the assessment boundary for each standard or performance expectation. In addition, one aspect of our standards that is a little unique from other disciplinary standards like math or ELA, there are also what we call foundational boxes present for every standard or performance expectation. The foundational boxes are these 3 boxes that are represented in a row at the bottom of this particular graphic. So science and engineering practice, disciplinary core ideas, and cross-cutting concepts. Those 3 boxes make up what we call foundational boxes. And that will give every teacher looking at this, or every educator looking at this particular standard, a little more information about what is intended related to planning and conducting investigations at this grade level, the disciplinary core ideas or science concepts that students should become familiar with to achieve proficiency with this standard, and that thinking skill that we really want students to practice through the cross-cutting concept that's embedded in that standard or performance expectation. Here for 3PS21, that cross-cutting concept is cause and effect. So hopefully you can see in the standard that students are engaged in the science and engineering practice of planning and conducting investigations. They're thinking about cause and effect as they do those investigations, and they noticed how something might have a balanced or affect balanced and unbalanced forces on the motion of an object. Again, for every standard, nearly every standard, you will find all of this information in our Oklahoma Academic Standards for Science. The layout is a bit new from our 2014 document, but the layout is new because we heard from the field of teachers in Oklahoma over the last several years that they would like for those standards to be a little bit more streamlined. And so our committee worked hard to provide that here. Next. As we're going through this, I want to mention that we will have a time for Q&A, but please continue to ask your questions in the chat box so that we can respond to those. The 3 major shifts, the 3 major shifts that you'll see associated with our standards include the addition of play-based pre-kindergarten standards. This is very exciting for many of our pre-K teachers because if you take a look at those pre-K standards, you'll notice that kids of that age are really involved in noticing and wondering the world around them. Engaging in the world around them is a major goal of those pre-K standards. Additionally, another shift associated with the standards is a stronger connection with the middle school grades. And third, an increased relevance for all students and increased clarification for teachers. We're going to go through some examples associated with these shifts in just a moment. We will also later in the presentation get into specific grade level and course level shifts for teachers to be aware of as they begin to think about planning next year. Susan, if you'll go to the next slide. Here's an example of one of those play-based pre-kindergarten standards or pre-K standards. Here we see that students will engage in play to explore the physical and natural world. But really, if you take a look at that clarification statement, you'll see that students are being asked to explore the physical and natural world by engaging in things that they might often already do in pre-K, like building towers with blocks, mixing watercolors, placing different objects in water. There isn't an emphasis to have students explain why some of the things happen that they notice, but simply to engage in productive play or investigative play and be able to share what they notice and they wonder. There's also an emphasis on inside the classroom investigative play as well as outside the classroom investigative play. Next. As Susan moves to that next slide, our second significant shift that we want to discuss with you is related to stronger grade level connections. This particularly impacts the middle school grade levels and in particular the placement of standards in the middle school grades. You will notice in the new Oklahoma Academic Standards that some standards that were in 6th grade may now be in 7th or 8th grade, or standards that were in 8th grade might now be in 7th or 6th grade. We wanted to share with you a little bit of the rationale behind those placement changes, but one of the things we want to share with you in this presentation is a document that will give you a better idea of where those standards have moved. And then on Thursday, we will have another webinar specifically for middle school teachers or curriculum coordinators who are supporting middle school teachers to help us all think through how you might begin to shift to those new standards because of those placements. So in this example, what we'd like to share with you is that there were a set of standards in the 2014 Oklahoma Academic Standards for Science, all related to chemical reactions and helping students understand chemical reactions deeply in that middle school grade level. Some of the standards, 3 of them represented here in orange, were in the 8th grade and 2 of them, represented in blue, were in the 7th grade. This was in 2014, and as Susan goes to the next slide, you will see in the new 2020 standards, all 5 of those standards that support students in deeply understanding chemical reactions are now in the 7th grade all together, so teachers can create better connections or stronger connections for students, leading to deeper learning about chemical reactions. Additionally, if we look at another example in this middle school grade, as Susan moves to the next slide, we saw that cellular respiration, which we understand occurs through a chemical reaction, was in 7th grade in 2014, but that companion process of photosynthesis, which also very deeply occurs through a chemical reaction, that was in 6th grade in the 2014 standards. So again, as Susan moves through the slide, we now see that both of these standards are now in 7th grade. And if we move to the next slide, I think it'll give you a broader picture of an example here. So again, all of these standards associated with helping students understand chemical reactions, both in the domain of physical science and then life science with cellular respiration and photosynthesis, they were in 3 different grade levels in the 2014 standards. Now in the 2020 standards, we see all of these standards together, and we should see that in just a moment as the slide transitions. Great, so now they are all there. We do see a couple of questions coming in the chat box related to assessment. We will talk about the timeline for assessment, and again, ensure that you are all aware that we do have time to transition to these new standards when it comes to assessment. So we're gonna go into that quite a bit in today's session as well. All right, next slide. The third shift that really led to some of the shifts that you will see at your grade level or course are related to increased relevance and clarity. Here's an example from 2nd grade where the original 2nd grade standard, make observations of plants and animals to compare the patterns of diversity of life in different habitats. The clarification statement here provided examples for students to explore different habitats that included their school, aquariums, and neighborhood. As the committee looked at that, they recognized that for some students, an aquarium may not be something that they have access to or have experienced in their lives. So it might be better to think about something that is more applicable to the lives of most students or diverse populations of students. And so here we see where that example has been changed to neighborhood parks, to ponds, and then to create a little clarity for teachers, rather than just saying school, around their school, it now says the school playground. Thank you, Susan. And now we're going to take a closer look at examining shifts associated with the standards by grade level. And so, Susan, I believe you're going to introduce us to some of those shifts. And since you're navigating your own computer, this should be a little easier.
Yes, thank you so much. All right, one of the identified quality attributes of science standards is that all 3 dimensions are explicit. As you begin to examine the standards at your grade level, you will most likely notice shifts making the 3 dimensions of science more explicit. Shifts include making a cross-cutting concept more explicit, changing it, or maybe you might notice there's a change in the science and engineering practice. For example, there was a change here in this cross-cutting concept in this 4th grade standard of PS 3.1. You'll notice that energy and matter was the cross-cutting concept in 2014, and that is now changed to patterns in the 2020 standards. Another quality attribute of the science standards was the increase of interest and relevance for all students. A shift you will also notice that Tiffany actually already highlighted in that 2nd grade standard, where the phenomenon of school, aquariums, and neighborhoods was changed to neighborhood parks and ponds, and then the school playground. The writing team examined the clarification statements for interest and relevance for all students, and therefore the shifts that you will notice include examples of phenomena that provide more clarification in the clarification statements that actually lead to more relevant examples for students. As you continue to examine the standards, you might notice that they are more clear, they're more concise and comprehensible. This is due to the shifts that include rewriting and adding clarification statements and assessment boundaries. And we have an example here. You'll see in this 5th grade standard, a brand new assessment boundary. And this was added to make it clear that this standard was not about students actually providing a molecular explanation of photosynthesis. And as noted earlier, these physical science standards were in different grade levels, and now they are all together, bundled together in that 7th grade. And this is to establish clear progressions in learning at the middle school grade band. The shifts include placement changes of standards throughout the middle school. Donna is now going to continue to share with you more shifts in the standards that lead to those attributes established by the writing team.
All right, the new standards reflect shifts in scientific accuracy, and the executive, writing, draft, and reconciliation teams use this lens to make standard-based improvements and adjustments where they were appropriate. For example, Susan, if you'd hover over the left side of the screen, for example, in the old MSLS 1-7, the expectation discussed that food was rearranged in chemical reactions. And the standards team noticed that it wasn't really the food that was being arranged in chemical reactions, but rather that the food molecules were being broken down and the elements or molecules were rearranged to form new matter that supports growth and or release of energy. So if you look on the right-hand side at 7.ls 1.7, the teams have made note of this change, which in turn creates a more scientifically accurate standard. Next slide, Susan. All right, so the new standards also reflected some shifts in rigor. And in order to accomplish this goal, it required a change in the naming nomenclature of our high school courses. As you can see, there is a performance expectation for both physical science and chemistry, but it is denoted with the abbreviation PS for the physical science and CH for the chemistry. And in the past, as you may well be aware, the 3 physical science courses, chemistry, physics, and physical science, shared the same standards. So in these standards, in the rewrite, you will see some major differences. In this example, the performance expectation is the same for both courses. So if you compare them left to right, it's the same. For simplicity, the performance expectation deals with the outcomes of chemical reactions based on periodic trends and valence electrons. In the next 2 slides, we're going to be looking at the difference in rigor. So this is where the rigor portion on this standard comes in. If you look on the left, you have the physical science clarification standard, and on the right, you have the new clarification statement for chemistry. In order to accomplish the goal of increased rigor, there were some changes made to the clarification statement. You will notice that the chemistry clarification statement includes examining the periodic trends of ionization energy, electronegativity, and reactivity. It also includes exposure to reactions, but also the prediction of products. In addition, chemistry includes a larger variety of reaction types. Rigor was increased for chemistry students by going into greater depth and complexity. Susan, would you push it to the next slide? Okay, using this same standard again, the assessment boundary was also changed. It is easy to see the difference in the rigor of these 2 assessment boundaries. A secondary sentence was added to chemistry to include the addition of polyatomic ions. Although this is just one example, it is important to know that there are clear distinctions in the new standards in physical science, chemistry, and physics. This is even true when there are common overlapping standards across the 3 physical science courses. In the next slide, we will look at some documents that should be helpful in analyzing some of these shifts in standards. Okay, let's take a moment, if you will, to look at some documents that have been developed to assist in analyzing the shifts with all of these attributes. So if we could take a deeper dive into third grade, Susan, if you don't mind opening up the third grade shift.
Susan, I sent you a link directly in your chat box. As we had to shift computers, Susan doesn't readily have that link up to show you all. And as she's preparing to show that link, what we want to share with you is we're going to give an overview of these documents that have been created to help you better understand the shifts for your grade level or course. And you certainly will have a link to them, but we would like to give Donna an opportunity to walk you through the document before we all dive in. And then just as many of our students would do, maybe are paying less attention to Donna's explanation of them. So we'll provide those links in just a moment.
I have the breakout rooms up, so I am struggling with getting that link up there.
How about I try, if you'll
okay, wait,
your
there,
screen?
I think. Here, I think I have it now. I'm sorry.
Susan, if it's not working, you're welcome to unshare your screen and I'll give it a go again and see if I can pull that up.
I have it.
All right.
Do you guys see it now?
Yes.
Okay.
Okay, if you could go to third grade, Susan.
Yes. I'm sorry, I'm attempting to do that and it is not opening. Here we go.
Okay, Susan's, yeah, she's got it up there. So this is a new document that's been created, and if you'll look at the top of the document for just a second, it does have a key. Susan, I don't know if you can scroll up.
Yep,
and so, yeah, so you will want to use this key as we work through it. And the blue color will denote no change. There wasn't any change from the 2014 to 2020. And then the orangish color, orangish tan, means there was a modification. And then the rusty red is that it is new. And then we also have the abbreviations for all the components of the standard. So if you want to go ahead and scroll down to grade 3 science. So this document represents all of the standards now that are in third grade science. And you can tell that for many of them, there were no change. However, on several of them, there were modifications as well as new. And for instance, on the 3PS2-4, where you see new for this cross-cutting concept, there wasn't one in the old document. So the team decided that it would be helpful to add that. And I think that guidance, I'm gonna let, as you explore these, I think that this document is helpful. And wouldn't it be nice if this document existed for all the science grade levels and courses? So the answer is, well, they do. And Susan, in just a moment, is going to discuss with you how you will have an opportunity to look at these documents and work in groups to explore them. Susan?
All right, getting everything ready for these breakout rooms. All right, at the beginning of this presentation, we went through steps to identify which breakout room that you will be in. So we wanted to make sure to go over those again for anybody that might have joined late. We would appreciate it if you renamed yourself, if you would rename yourself. And by doing that, you could just go down to the bottom of your screen. And at the bottom of your screen, you will see, if you hover over the bottom, you will see participants. and you click on participants, it will pull up a panel and it will show all of the participants. Your name should be at the very top. And when you click on your name, it will show, you will see the word more. You click on more and you will see rename. This gives you the ability to rename yourself. And when you rename yourself, if you will, put one of these numbers, depending on the grade level or course that you would like to collaborate with. You will put one of those numbers in front of your name. And there are some creative numbers in front of some of these names. So if you end up in the wrong breakout room, if you will just exit, I will make sure you get put back in the right breakout room. But I have most of you assigned. Prior to this, there were about 10 people that weren't assigned. If you are not assigned and you end up, I will be in this room, and so I will make sure you get to the room that you want to go to. Once you get into that room, so in a minute I will put you in breakout rooms, it will ask you to join. If you will please click join this group. You will be able to click on these links here. We have a link for each group. And in that link, you will find discussion questions. You will open up the documents that Donna just shared with you. Take a moment to look over those documents. Think about what you're wondering about them. What are you noticing about them? And then go ahead and start answering some of those questions together. Have a really good discussion together about those questions. If you will, please designate a note taker and someone that would be willing to share your group's responses to those questions. And the questions that you are going to be sharing are listed here on the screen. So we just want you to really think about what you notice and wonder about the shifts and the non-shifts in your grade level or course. Also, how does this information help you think about instruction based on the shifts? And then what do you think